So we're going to be looking at quadratic functions. Note, quadratic functions are typically functions that look on our XY graph, like something like that, or maybe something like this, also known as parabolas. Okay, so a quadratic function is typically going to look along the form of f of x equals ax squared plus bx plus c, where note where a can equal 0, or other words that this is a polynomial of degree 2. So sometimes, a lot of times, we're going to be interested in when does this f of x function equal to 0, when the whole thing equals to 0. And we can do that by factoring. That's what we've done so far in class. But we can always use what we're going to call the quadratic equation, where x will equal to negative b plus minus the square root of b squared minus 4ac, all divided by 2a. So we can always plug in, use the quadratic equation to solve for when a quadratic function equals 0. So let's take a look at this example that we got right here. F of x equals to minus x squared plus 5x plus 6. So let's go through what values a, b, and c are. A is going to be the coefficient in front of our x term. So a equals to minus 1 here. B is the coefficient in front of our x term. B equals to 5. And 6 is going to be our c, and that is because that is the constant term. So now we can plug these values for a, b, and c into this quadratic equation right here to be able to solve for what x equals to. So let's do that. X equals to minus b plus minus the square root of b squared minus 4 times a times c. C is 6, all divided by 2 times a. So let's start solving this. 25 squared equals 25, minus 4 times 6 is 24 times negative 1, so we got minus 24, all divided by negative 2. So x equals to minus 5 plus minus the square root of 25 minus negative 24, or 49, divided by minus 2. Here we're going to have x equals to minus 5 plus minus 7 divided by minus 2. No, I keep saying plus minus. That's dealing with that right there. That's because we have to not only, this is going to have two solutions this time, where one of the solutions is where x equals minus 5 plus 7 divided by minus 2. And we're also going to have a solution at minus 5 minus 7 divided by 2. So we're going to have two different solutions, one where we plus the 7 and one where we minus the 7. So if we look over here, we are going to get x equals to so minus 5 plus 7 is positive 2. Positive 2 divided by negative 2 is minus 1. So that's one solution. And over here, minus 5 minus 7 is negative 12. Negative 12 divided by 2 is we're going to get x equals to, that should be a minus 2 down there. So positive 6. So those are our two solutions. No, let's go back to our original function. F of x equals to minus x squared plus 5x plus 6. We've also done this solving factoring, where we could have minus 1 times x squared minus 5x minus 6, and this equals minus 1 x minus 6 x plus 1. And then if we have 0, if this function equals 0, then we know that x equals to positive 6 and x equals to negative 1 will give us the values of x that will make our function equal to 0. So that's two different ways that we could have solved this problem. We could have solved it done in factoring, or we could have used the quadratic equation. So no, not everything can be factored like we did, but we can always use the quadratic equation if we want to solve for x's to make our function equal to 0. Alright, so that was a time where we got nice clean values of x. X equals -1, x equals 6. Let's do an example where we don't get such clean answers. Things can get a little messy sometimes. So let's look at this. Let's look at this equation right here. So we want to figure out what a, b, and c equals to. A equals to -1, and that is because that is the coefficient in front of our x squared term. B equals to +5, because that is the coefficient in front of our x term. And c equals to 3, because that is our constant term. Alright, so we can plug that into our quadratic equation. So we're going to get x equals to -b plus minus the square root of b squared minus 4ac, all divided by 2 times sorry about that, things were acting a little funny for me. 2 times a. Alright, let's clean this up a little bit. So we're going to get x equals to -5 plus minus the square root of 25 plus 12, all divided by -2, or otherwise known as x equals to -5 plus or minus the square root of 37 divided by -2. Note, the square root of 37 isn't some nice clean number, so 37 isn't a perfect square. So we're going to get x equals to -5 plus minus, well, the square root of 37 is about 6.08, all divided by -2. So now we have to solve for x equals to -5 plus 6.08 divided by -2, and we have to solve for when x equals to -5 minus 6.08 divided by -2. And we're going to get the solutions of x equals to -0.54, or we're also going to get the answers of x equals to 5.54. Alright, so those are our two values of x. Now notice, one way that we could think about this is that we're solving for all the x values where this function equals to 0. That's also known as where the x is solving for the x-intercepts. Alright, so we have been looking at equations where it's written in ax squared plus bx plus c form. We are also going to be interested in what we call vertex form. Vertex form looks like f of x equals to a times x minus h squared plus k, where h and k is the vertex. So in this parabola we got going on right here, the vertex is the most minimumist point, where we had the vertex. Instead of calling it xy, because we want to denote that as a vertex, we're calling that is the point hk. So let's look at an example where we have f of x equals to 5 times x minus 2 plus 3, and we just wanted to graph that guy. Well, then we know that h equals to +2 and k equals to +3. So if we were to try to graph that, 1, 2, 1, 2, 3, that would be our vertex. And because our a value is positive, our parabola opens upwards. Alright, so we're going to be interested in a concept called completing the square, where we have our function given to us, and f of x equals to ax squared plus bx plus c, and we're going to want to figure out what is this equation equal to in vertex form. And to be able to do that, we're going to do a process called completing the square. So we want to be able to rewrite this in the form f of x equals to a times x minus h squared plus k. Alright, so the way that we are going to do this is first we are going to look at our terms that have x in them, and we're going to factor out the coefficient in front of our x squared term. So we got to factor out a negative 2 from negative 2x squared plus 16x. So we're going to get f of x equals to minus 2 times x squared minus 8x, and then minus 24. So remember, we just factored out of our x's. We didn't factor out that minus 2 from our c term over there. Alright, so now this is the same. Now what we are going to do is f of x equals to minus 2 x squared minus 8x plus something minus 24 plus something. And what we want to do is make this inside the parentheses, we want to make this a perfect square. So how do we make this a perfect square? If we have 16 inside that parentheses right there, now this parenthesis right here is a perfect square. But note, if we added 16 inside the parentheses, what we really did was subtracted 32. Because we have minus 2 times 16, and we subtracted 32. And because we subtracted 32, we're going to want to make sure that we add 32 on the right-hand side of the equation as well. Alright, so f of x equals to minus 2. Now we have that perfect squared, x minus 4 squared. And then what's negative minus 24 plus 32? Well, we just got plus 8. And now we have rewritten f of x in vertex form, where h equals to positive 4 and k equals to positive 8. And if we wanted to graph this, we would go to the right 4 units, 1, 2, 3, 4, up 8 units, 1, 2, 3, 4, 5, 6, 7, 8. Plot our vertex, and because our a term minus 2 is a negative number, that means our parabola is going to open down. Alright, so let's do another completing the square example, because I know that this can get a little tricky. So once again, we have our equation written in f of x equals ax squared minus bx plus 21. And what first thing we're going to do is factor out this coefficient in front of our x squared term to both of our x terms. So we're going to get f of x equals to 0.5 times x squared. If we factor out 0.5 from 6x, we're going to get minus 12x plus 21. Now we're going to write f of x equals to 0.5 x squared minus 12x plus something plus 21 plus something. Alright, so now we got to figure out, we want to make this parentheses a perfect square. So if we plus 36 in the middle right here, now our inside of parentheses is a perfect square. But note that if we're adding 36 inside the parentheses, what we're really doing is adding 18 to the right hand side of the equation, because 0.5 times 36 is 18. Now if we added 18 to the right hand side of the equation, we want to make sure that we subtract 18 from the right side of the equation as well. Alright, so we got f of x equals to 0.5 times x minus 6 squared plus 3 now. Where, so this is, now we have written in vertex form, where h equals to positive 6 and k equals to 3. And if we were to plot that, 1, 2, 3, 4, 5, 6, 1, 2, 3, that would be our vertex. And because our a term is positive, our parabola would open upwards. Alright, if you are having a hard time figuring out what value do I put right here to make sure that I have a perfect squared, well, we can always look at this term here and divide it by 2 and then square it. So we have minus 12 divided by 2 equals negative 6, and then negative 6 squared equals 36. So that's how we can get 36 in there. So if we look at our previous example, where we were trying to figure out what to put right here. Well, if you couldn't figure out, I need to put a 16 inside that parentheses. One way that we can do it, we're going to look at this coefficient here. So minus 8 divided by 2 equals to minus 4. And then minus 4 squared equals to 16. So note, that is the value that we're going to add inside the parentheses. So we would always have our coefficient in front of our x variable divided by 2, then that number squared. Alright, so let's do a standard word problem type thing. So let's imagine that we have our revenue function as, that's r of x, revenue function as x times 75 minus 3x, and our cost function is 125 plus 16x. And we might be interested in graphing both r of x and c of x. So the way that we can graph r of x is to be able to rewrite it in vertex form. So if r of x equals to x times 75 minus 3x, then we know r of x equals to minus 3x squared plus 75x. And then we can rewrite this in vertex form. It's going to get a little messy, but this will equal to minus 3 times x squared minus 25x plus nothing right now. And now we're going to get minus equals to minus 3 x squared minus 25x plus something plus 0. To make this a perfect squared, we're going to have that 25 and then square it. So half of 25 is 12.5. If we square that, we are going to be getting 156.25. Now notice if we're adding 156.25 inside the parentheses, we are really subtracting minus 468.75, because that is what negative 3 times 156.25 equals to. So if we are subtracting 426.75 and on the right hand side of the equation, then we're also going to have to add 468.75 on the right hand side of the equation. Alright, so this will equal to minus 3 times x minus 12.5 squared plus 468.75. So if we wanted to plot that, we would have our x, our h value equals to 12.5, and our y value for our vertex is 4 468.75. And because our A is minus 3, so it means that our parentheses are going to open downwards. So that is our revenue function. And if we wanted to plot the cost function, we would have a y-intercept of 125. And we're going to have a slope of 16 units. I'm just going to draw a straight line with the upward slope. So we have our cost function and we have our revenue function. Alright, so notice that this is our revenue function. And we can see where our revenue function is greater than our cost function. Where revenue is greater than cost, that is going to be where our firm is earning profit. Alright, so find the break-even points. The break-even points is going to be when revenue minus cost equals to 0. So if we have our profit function of x will equal to our revenue function of x minus our cost function of x. And if we want to solve for where profit equal to 0, that would be just where revenue minus cost. So what is our revenue function again? So we're going to have 0 equals to x times 75 minus 3x, that was our original revenue function, minus our cost function, which is 125 minus 6, plus 16x. So we need to do some work and try to figure out. So this is the profit function. So let's simplify this a little bit. We'll get 0 equals to minus 3x squared plus 75x minus 16x minus 125. And we are going to get this equals to minus 3x squared, 75x minus 16x. We're going to get plus 59x minus 125. And now this equals to 0. This is kind of like what we started with on today's lecture. So we want to solve for where this equals to 0. So A equals to minus 3, B equals to 59, and C equals to minus 125. And we can now plug this into our quadratic equation. So we're going to get x equals to minus 59 plus minus square root of 59 squared minus 4 times negative 3 times minus 125. All divided by 2 times minus 3. And we're going to get, this is going to take some work, 59 squared equals to 3,481 minus 4 times minus 3 times 125 equals to minus 15. It should be positive. All divided by minus 6. X equals to minus 59 plus minus square root of 3,481 plus 1,500, and we're going to get 4,081 all divided by minus 6. If we take the square root of 4,081 981, we're going to get x equals to minus 59 plus minus 70.6 roughly divided by minus 6. We're going to get, now we got to do both versions, so we're going to do the positive one first, so minus 59 plus 70.6 all divided by minus 6. You get positive 11.57 divided by minus 6, or we're going to get x roughly equals to minus 1.9. Alright, if we would do the negative version, we're going to get x equals to minus 59 minus 70.6 all divided by minus 6. We're going to get minus 129.6 all divided by minus 6. $129.6 x equals to positive 21.6. So we got our two, let's say, theoretical break-even points, where x equals minus 1.9 and x equals 21.6. Remember, our original revenue function looks like this, and then we had our cost function cutting through here, and note we have x values equal to minus 0.19 and x equals to 21.6. So our break-even points is going to be where we're producing negative 1.9 to positive 21.6. But note, we can never produce negative units, so we're just going to say that our break-even values is from 0 to 21.6. Alright, and now we can ask the question, for which values did a loss occur? Remember, the loss occurs whenever our costs are greater than our revenue. So we got our revenue function, we got our cost function, and we know that at this value we have 21.6 units. So for all units greater than 21, C of x is greater than R of x and will incur an economic loss. Alright, so that does it for today.